Hello and welcome to my video on Introduction to Polynomials. So first of all, let's look at the word polynomial. And hopefully you might start recognizing that there's two parts, poly and nomial. And the first part, poly, I'm going to tell you here, and you might remember from something else, means multi, or many, or multiple, or something like that. And nomial, I'm going to say it's terms, but you might think of number instead, so multiple number, or in my argument here in a second, multi-termed. Okay, so we're talking about the number of terms in something. So there's a monomial, binomial, trinomial, and anything above a monomial is a polynomial. It's got multiple terms. So how many do you think a monomial has? Well, mon means one, so one term. Binomial, bi, like a bicycle, two terms. And you can take a look at my binomial video for that one. Trinomial, tri, like a tricycle, three terms. All right. So here is a polynomial. And first of all, how many terms are there? Well, if we count them, we're going to count them like this. 1, 2, 3. So this is a trinomial. Now I'm going to ask a little question here. What happens if I add 4? Is it now a quadnomial or polynomial bigger than trinomial? Well, no. Because 2 and 4 have the same degree, which we're going to define in a second, we can add them together to give us plus 6. So we still count that as one term. So there are still 3 terms, so it's still a trinomial. Okay. So let's go down here and look at some definitions here. So first of all, degree. Well, degree, I'm gonna write down sort of I'm gonna show you. So it's the exponent of the greatest term. Okay? Or the greatest exponents of any of the terms. So in this case, in our original polynomial, here, our greatest exponent is that 2. Okay? But we still have exponents here, just an invisible exponent of 1. And here, this is the most tricky one. We actually have an exponent, 2 times x to the 0. So if you remember, anything to the 0 equals 1. So 1 times 2 is still 2. So we can say that has a degree of 0. Okay? So now let's define term. Exponent of the greatest term. Of a variable. So if you have an exponent of a number, it doesn't count. Let's just add that there. Okay, so what about terms? Well, we're looking at how many terms. So a term is a set of numbers for a specific degree. So because my two numbers, 2 and 4, both have degree 0, they're all one term. If I had two things of degree 2, it'd both be one term. Okay? Constant is a term with degree 0. So in this case, like 2 or 4, any number at all, as long as it doesn't have an x beside it. And term is like anything like x squared, 2x, like anything like that. A variable is any any letter representing an unknown number. So the most common ones are X, Y, Z, A, B, C, and N. But there could be any other letter. Coefficient is the number in front of or multiplied by a variable. So if you look at this one here, that is a coefficient of 3. Okay, so one thing to try to think about, to try to remember some of this stuff, is sort of this sort of way of representing the polynomial. Alright, so we've got these here, and how do we represent it? Well, I don't know yet, so, well, I do know, but we don't know yet, so let's try it with something else. What if x is 10? Let's try it again if x is 10. So let's write this whole thing out. And you might remember that you can have algebra tiles, or you can have shapes that represent this. So if you have cubed, it's volume. So if we draw that out, we're going to actually end up with a cube. Okay, and how many cubes are there? Well, there's actually a coefficient of 1 there that you just don't know. Okay, so it's 1. Whoops. And now for this other one, well, if you square something, it's like having a square. No surprise there. Or it's the area. And if it's just 3 times 10, it's just long like sticks. It's just the length. And then the other one is just small squares, unit squares. Okay? So this one, we can say that each of the sides is 10. The length, the width, the height. This one we can say the width and the length are 10. And this one we can say the length is 10. Right? But here, on this with x's, we don't know what the side lengths are. We have x, 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 x. It could be any number. So this could be any number here, and these are unit tiles. So what you can maybe notice once we draw it out like this is that these here are not the same as these here. And they're not the same as these here. And they're not the same as this one here. So because none of these are the same, we can call each one of those different terms. If, let's say, we added another one here and we said plus 2, well, we'd have another 2, but really it's the same thing as these ones, right? So we just actually say it as 6. So we think of that as one term. And that hopefully helps explain some of those terms. I hope this video helps with Introduction to Polynomials.